Hey there, science fans. Today, we're diving into the exciting world of technology. And guess what? It all starts with a simple number 2. That's right, the power of 2 is what makes our computers, smartphones, and gadgets tick. Think of it like this. Computers are like giant light switches, but instead of just on and off, they use 0 and 1. This is called binary code, and it's how computers understand everything we tell them to do. Each 0 or 1 is a bit, like a tiny piece of information. Now here's where the power of 2 comes in. Every time we add another bit, we double the number of possibilities. 1 bit gives us 2 options, 0 or 1. 2 bits give us 4, 0, 0, 0, 1, 1, 0, 1, 1. 3 bits give us 8, and so on. See the pattern? It's like magic, but it's just math. This simple concept of doubling with each additional bit is the foundation of all digital technology. Pretty cool, right? Stick with me and we'll explore how this power of 2 magic works in everything from storing your favorite photos to playing awesome video games. Let's talk about how computers actually think. They don't have brains like ours. Instead, they use a special language called binary code. Imagine a light switch that can be either on or off. That's like a single bit in binary. On could be represented by a 1 and off by a 0. Now imagine a string of these light switches. Each switch can be on or off, creating different combinations. With 2 switches, we have 4 possibilities: off-off, off-on, on-off, and on-on. Each of these combinations can represent something different to a computer, like a letter, a number, or a symbol. That's essentially how binary code works. By stringing together zeros and ones, we can create complex instructions and data that computers understand. And since each bit doubles the possibilities, we can represent a huge amount of information using just these 2 simple digits. Think of it like Morse code, where dots and dashes combine to create letters and words. Binary is similar, but instead of dots and dashes, we have zeros and ones. And just like Morse code allowed us to send messages over long distances, binary code allows us to communicate with and control the amazing world of computers. Okay, so we know computers think in binary, using zeros and ones, but how do we measure all this data? That's where bytes come in. A byte is like a little package of information, usually made up of 8 bits. Think of it as a bite-sized box that can hold 8 of those on or off switches. With 8 bits in a byte, we have 256 possible combinations, 2 to the power of 8. That's enough to represent all the letters in the alphabet, numbers, and lots of symbols. Pretty impressive for just 8 little bits. Now let's talk memory. You know how your computer has RAM and storage? Those are like its brain and its filing cabinet. And guess what? They're measured in powers of 2 too. You'll see things like kilobytes, megabytes, gigabytes, and terabytes. Each one is 1,024 times bigger than the last. Why 1,024? Because it's 2 to the power of 10. See, the power of 2 is everywhere in the digital world. Let's visualize this. Imagine a single pixel on your computer screen. It can be either on or off, just like our binary bit. Now imagine a row of 8 pixels. That's like a byte. Now imagine a whole screen made up of these rows of pixels. That's a lot of bytes, and each time we double the number of pixels, we double the amount of information we can display. That's why higher resolutions look so much sharper and more detailed. Think of it like building a tower with blocks. If each block represents a bit, then 8 blocks stacked together would be a byte. And as we add more and more blocks, bits, we can build taller and more complex structures, data. This concept applies to everything in the digital world, from the simplest text messages to the most complex video games. It's all about arranging those zeros and ones in different ways, and the power of 2 helps us understand how much information we can store and process. Section 5, from tiny files to gigantic downloads, it's all powers of 2. Ever wondered why file sizes are often in those weird numbers like 1.54 megabytes or 2.8 gigabytes? It's those powers of 2 again. Remember, computers think in bytes, which are groups of 8 bits, and file sizes are just a way of measuring how many bytes a file uses. A small text file might only be a few kilobytes, while a high-resolution photo could be several megabytes. And a full-length movie? That could easily be several gigabytes. The bigger the file, the more bytes it takes up and the longer it takes to download or copy. It's like moving boxes. A small box is easy to carry, but a giant box takes more time and effort. Understanding these file sizes helps us manage our digital stuff. We know that a 16 gigabyte flash drive can hold a lot more photos than a 2 gigabyte one, and we know that downloading a 5 gigabyte game will take longer than downloading a 5 megabyte song. It's all about those powers of 2. Section 6. Supercharging your tech skills, why powers of 2 matter. Now you might be thinking, this is all very interesting, Bill, but why do I need to know this? Well, understanding powers of 2 can actually make you a tech superstar. For programmers, it's essential. They use binary code and powers of 2 every day to write the software that makes our computers and smartphones work. Knowing how data is stored and accessed helps them write more efficient and powerful code. But even if you're not a coding whiz, understanding these concepts can help you troubleshoot tech problems, make informed decisions about storage and memory upgrades, and just appreciate the magic happening inside your devices. For example, if you know that your phone's storage is almost full, you can start deleting large files to free up space. Or if you're having performance issues on your computer, you might need to upgrade your RAM. And knowing how RAM is measured in powers of 2 can help you choose the right upgrade. Section 7. Real-world examples, powers of 2 all around us. The power of 2 isn't just confined to the digital world, we see it in action all around us. Think about music. A standard musical octave has 12 notes and each octave doubles in frequency. That's a power of 2 relationship. Or how about photography? Camera lenses often have aperture settings that increase in size by a factor of 2, like f/2.8, f4, f/5.6, and so on. Each stop lets in twice as much light, another example of the power of 2. Even in nature we see powers of 2 at work. Think about cell division. One cell divides into 2, then those 2 divide into 4, and so on. It's an exponential process driven by the power of 2. So, the next time you hear about bits, bytes, or file sizes, remember that it all comes back to that simple but powerful concept, the power of 2. It's the foundation of our digital world and a fundamental principle that pops up in surprising places. Section 8. Optimizing your tech. A little knowledge goes a long way. Knowing about powers of 2 can even help you get the most out of your tech. When you understand how storage works, you can organize your files more efficiently. You can compress large files to make them smaller. You can even optimize your internet speed by understanding how data is transferred in packets. Think of it like packing a suitcase. If you just throw everything in randomly, it takes up more space. But if you carefully fold your clothes and pack strategically, you can fit more in. The same goes for your digital data. By understanding the basics of how computers think and store information, you can make smarter choices about your devices and use them more effectively. It's like having a secret decoder ring for the digital world. Section 9. Keep exploring the power of 2. So there you have it. The power of 2 is the secret code behind our amazing technological world. It's in our computers, our smartphones, our music, and even in the way nature itself works. Who knew that such a simple concept could be so powerful? I encourage you to keep exploring and learning about the fascinating world of technology. There's always something new to discover, and understanding the basics like powers of 2 can unlock a deeper appreciation for the magic happening all around us. Keep asking questions, keep experimenting, and keep that spirit of scientific curiosity alive. And remember, science rules.